Okay, so we're back looking at the single table design for DynamoDB when we use DynamoDB for AWS as, contact center, AWS Connect, and what we're trying to figure out is how to design our table. Now, what we're going to do is eventually say, oh, we need to look at the access patterns to try to figure out what we want to do. Do we want the query by agent? Do we want to query by customer phone number? Do we want to query by queue? What are we trying to do with DynamoDB? And what are those access patterns? And based on that, we answer these questions. So the first time, and like I said, these projects usually things get things happen, and there's no access patterns documented, and usually the stuff works, but you might be paying a lot of money. So it's always good to look at best practice. But quickly thinking about what are we trying to do here? So one approach I saw on the internet, which I actually implemented um, for one table, was you could use a unique identifier for the instance as a partition key. Um, this is really good because I know that it, on one hand, it's good because you could have multiple instances um, in your table. On the other hand, I'm not too crazy about managing multiple instance aliases within a single table. So it's going to get complicated, and so I'm thinking about this. But this was the recommendation from Amazon, let's say. And the sort key, you could use different views like a user, pound, user ID. And this is so the user ID is unique. Um, and 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 when I think of this, I'm like, yeah, user ID is fine, but really I might want to segregate agents from customers and admins and stuff. So I might not want to use this name for a secondary key. Uh, the sort key can be Q pound QID, and the thing about that is the thing about that is that you could only have one sort key with the partition key. Now, what I can do with the QID is use a local secondary index for another sort key. But the local secondary index has to be created when you create the table. So now I created a table without that secondary sort key, and I'm like, well, I feel restricted already. I'm using an instance alias as a partition key. I'm using a user pound user ID for a sort key, and I need to sort on my queues and query my queues, and I'm already not too happy. And I didn't create the local secondary index. So if I go back and drop the table and create a local secondary index, I still have a partition key, instance alias, a sort key um, with a user ID, and then a local secondary index with the QID. And so I could sort by QID and user. And I'm saying, well, I don't know how I feel about that either because I don't even know what my access patterns are right now. I might be looking up call history. I might be looking up agent to agent communication. I might be looking up uh, uh, a customer with an agent with a long queue time, available queues, waiting times. There's a lot of things I might do, but this is one approach and one thing to think about. And I thought about it, and I don't like it. Okay, and what I'm deciding to do with my production account is use a single table design and use a partition key called partition key, and a sort key called sort key, and I'm going to be able to use any records I want in those keys, and I could query. And so, with that said, the attributes of the agents, the customers, the queues, um, you know, I have the ability to do that. Now, what I'm losing is my instance alias, and I might be able to live with that right now because I think querying based on an instance alias for a couple of years when I'm only going to have one instance doesn't seem to make sense to me. Um, but anyway, putting that aside, you do have to you have to figure out what your partition key or sort key is, and then what attributes you're going to be using and why. And so, too early in the stage to do a single table design. Let me um let me move forward here. So with a single table design, you want to store connect instance details and relevant information efficiently. That's the main goal. When you're querying, when your workflows and your Lexbots and everything and your React application is querying this stuff, you want it to be very efficient. And if you change something like a queue, a routing profile or a queue, you want to be able to change that in production without breaking everything. So the composite key, which is the partition key and the sort key, is used to organize data and enable fast queries based on different access patterns. This design allows you to retrieve data relative to a specific instance, user, channel, etc. Single query. So this is so the black box here is what we're trying to do. So let me explain the black box a little bit, okay? When you store data into DynamoDB, it gets stored on 6 different nodes. It's spread out, so it's high availability and it performs well. So when you query data, what you want to do is make sure that you're pointing to a node to get information and you're sorting by keys in that on that node. So if the data is split out to 6 different nodes, basically you want to make sure that when you're writing to this table, it's being spread out. So different primary keys will be stored different places, and different secondary keys will be queried within those nodes, so you get the performance. Okay, so this really isn't a design course, but you could look at the NoSQL developer and get the picture. You could look at Alex Debris and other folks in Amazon who do single table design. What we're trying to do is just trying. I think what I'm trying to do here is trying to figure out what not to do and go with particular pattern. And I think I know what my pattern is right now. But let me move forward so we continue the conversation. Okay, so AWS Connect is using DynamoDB. And when you have a big application in Amazon Connect, what you're doing, you need to set up the DynamoDB table defining its schema and then use AWS Connect APIs or other integration methods to read and write data to DynamoDB table. So typically what's done is you have a workflow, and in the workflow you get the customer's phone number, you get some information from their Salesforce contact profile, like their email, whatever it might be. And then the Lambda, the Node.js Lambda inside your application that's connected to your workflow, your Lexbot, or whatever it is going to write information into DynamoDB. Now, I'm just saying that it's a simple use case. You're writing a record. And let's suppose the record is the primary key is the customer phone number, the secondary key is how I'm going to sort by that. Uh, so I have to figure that out. But the SDK or application, whatever you want to call this, a React application or the AWS Connect application as a whole, uses SDKs, and they use the web API for DynamoDB. And you lose track that it's really calling an API, but it's really like an SDK. So your Lambda is Node.js. You're calling this Node.js object, and you're saying write to DynamoDB or read from DynamoDB. So basically, there's action going on behind the scenes where these lambdas are writing to DynamoDB. Um, and you want this thing to scale when it writes to DynamoDB. spread out across multiple nodes. And when you read from DynamoDB and sort, and you got to look at all these operations and make sure it's performing properly. Okay. The other thing in some of these applications when you write to DynamoDB is you trigger use DynamoDB streams, and what happens is you could use a Lambda to read and write from these streams. So as you're updating data in DynamoDB, what happens is the records that you're updating go into your Lambda, and you could read those records and process them and write them somewhere else. And so I don't particularly like this picture, but if I built a React app with a front end and there were read and write operations, it would be pretty clear what's going on with DynamoDB. But in Amazon Connect, it's really the workflows that have Lambda hooks that write to DynamoDB or read from DynamoDB, and all the logic and the workflow for the Amazon for the core workflow uh, is 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 doing these things. So it's fair to say that there's lambdas reading and writing, there's streams that are happening, and lambdas are getting invoked, and then you got to worry about the performance and how the data is being read and written and consistency and everything else like that. Okay, so let's move on. Okay, so setting up DynamoDB, the best practice steps using a single table design and development. First, look at your data access patterns. You write down your data access patterns. This is not only for designing a table properly, but mostly used for that. How am I reading? How am I writing? But it also makes you understand more about your application and how your application is accessing, which is just as important because you don't want to do things inefficiently within your application. So you want to optimize in DynamoDB, but at the same time, um, you when you look at the data access patterns, you document them, gives you a good idea of what's happening within your application and whether what you're doing is correct or incorrect, whether you feel comfortable or discomfort. Now, I highly recommend after you document these patterns, you go into NoSQL Developer, you use this tool for single table design. You can create and deploy your table, and you could store connect related data. This could include information like customer profiles, interaction details, routing rules. Now, one thing about NoSQL Developer is it comes with single table designs that are already examples, and you could see, how did they create the primary key? How did they create the secondary key in an e-commerce and an order application? Um, uh, there's all these different examples, so you could look at them, and you could download this tool for free. And I guarantee you, when you design a table and you deploy the table and you point to Amazon accounts, you can go back and forth between different Amazon accounts and pull and push, and it's really good. So um, a little bit of learning curve, but once you get into it, it should be part of your everyday practice. Okay, now this define schema determine the attributes, the fields you'll store in your table, and their data types. Are they string? Are they number? Are they list? You need to define a partition key and sort key, if needed, to uniquely identify items in the table and enable efficient querying. So there's a lot going on here. Okay, so the access patterns tell you what you need to query, what you need to write and read, and what you're trying to do. And uh, the partition key and the sort key determine how to optimize that when using DynamoDB. Okay, so this is like a little summary slide here. We're connecting AWS and connecting AWS Connect to DynamoDB. Okay, so there's ways to do it, right? There's API integration. You could use AWS Connect's API to interact with a DynamoDB table. you could use the API to create a new customer record in DynamoDB when a new contact is added to connect, or to retrieve customer details from DynamoDB during a call. Um, and um, and there's also Lambda functions, right? So 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 it's good with the API integration. It's good to know what API connects APIs are. And there's a lot of them, and they could do a lot of different things. And should I build something or is something there? Okay, so that's a loaded question. But you're custom developing things you want to develop, and you're using things that are out of the box. So just keep that in mind. With Lambda functions, you could integrate Lambda functions with AWS Connect to perform actions like updating Dynamo when a contact is transferred or when a task is completed. Now, this is relatively simple, but it's just like everything else. You gotta do it and test it and make sure everything works. So with a workflow, I could say, okay, at this step, I want a Lambda function to persist into DynamoDB. So one, I need the Lambda function first, so the workflow can invoke it. I need to register the Lambda function with my Connect instance, so the workflow can access it. So there's a lot of dependencies here, but once you know what you're doing, you can do these things very easily. Um, and so, this is talking about the contact flows. You could use the invoke Lambda function block in your connect contact flow to trigger Lambda functions that interact with DynamoDB. And like I said, that goes for okay, we're going to route this user to this agent because this customer is Spanish speaking and we need that Spanish agent. But wait a minute, the agent is out to lunch. So what are we gonna do? Let's give him a call back. He goes into a different flow. We're gonna give him a call back and blah blah blah. Whatever the logic may be, it gets complicated and it's and you're always trying to do the right thing to please the customer, and it's always it's always work to do that. Okay, so let's look at scenarios. Okay, scenarios. Storing customer profiles. When you create a DynamoDB table with attributes like customer ID, name, phone number, and email, we could use AWS Connect APIs to store the data when the customer is added or updated. Okay, so think about this. Customer profiles these days mean you're using contact center customer profiles, which means Salesforce customer objects, contacts, or whatever you want to call them are getting pushed into AppFlow and coming into your AWS Connect system. When the customer calls in, they're calling in with their phone number, and their phone number is used to go get the customer profile. So now you have the customer email, you have the customer information, and so you're pumping stuff into DynamoDB table, and you have their service now tickets and their call history and everything in there. And so this is what I see when I hear customer profiles. But right now, I mean, the simplest scenario is customers calling in. I get their phone number. I'm gonna go through a workflow and tell them we're gonna call them back as soon as possible, and I'm gonna store that in DynamoDB. And I might ask them. I'm not, I have the option to ask them for their email or not. Um, but let's say I say I don't. I'm going to get their phone number and put it in a DynamoDB table. Now, if I have millions of customers coming in and I'm asking them for the phone number, I want to make sure I'm writing that as efficiently as possible. So that's when the primary key would be the phone number. And as the writes are happening, they're getting a spread across all the nodes. And I don't know if ordering comes into play here, but yet, but at least my primary keys are writing to different nodes and it's getting spread out. The data is getting spread out, etc. Okay, the next item is tracking call interactions. And this is, you can store details about each call, the agent's name, the call duration, any notes, and it could be useful for analytics and quality assurance. But like I said, if you look at, and so you make the decision, do I need to track this in DynamoDB? Wait a minute, I'm going to activate Contact Lens. Contact Lens keeps track of the agents and customer interactions, performance and everything, and there's dashboards there that you could look at. And so I might not want to do this. Um, but So it all depends on what objects I'm trying to model in DynamoDB. And then there's dynamic routing calls. Use data from DynamoDB to dynamically route calls based on customer profile attributes or call history. Okay, so this customer has a ticket open. He's called in 3 times, and now he calls in again the 4th time. I want to make sure I see the call history. I see this has a problem for more than 3 days. I'm going to route him to a particular queue where he's going to get a better expert, resolve the problem. And let's say that's an agent. Let's suppose that's a queue where the agent supervisor's answering on that queue. Let's say that. So these are all different example scenarios. Some example scenarios you could think of. Okay, so and this is the best practice. Okay. And I say this because it's true. I say this because um, I say this because everyone skips steps, of course. But when you're doing single table design, um, you make the decision to do it, right? So right now I have a decision. Do I want a separate agent table, a separate customer table, separate queue table? What am I looking for here? Well, I want a single table design. Single table I want, and being referenced these objects different ways efficiently and optimized. So that's the answer to my question that I'm asking myself. So I always go with single table design. You optimize for your access patterns. You always document your use case access patterns before you choose your partition or sort keys. And I feel very strongly about this because if you don't, you wind up dropping your tables and designing differently. Now, in some cases, it's very, very easy. We did a branding problem where we had 5 different lines of business, and different lines of business had a different theme. Something like that is very simple. You have the partition key as different lines of business, and they're being spread out across the nodes, and it's simple enough to say, yeah, I know what I'm doing, but it's never a good practice to skip access patterns, um, because when you look at access patterns and you document them, then you're starting to get a real good idea of where you're heading and what you should do. Okay, and this next item says use Dynamo streams. The advantage of streams is that the Lambda doesn't trigger until the data is triggered, and that I'm having, it's very important that you get notified precisely when the update is happening in DynamoDB. If you don't, like some of the AI projects I'm in, you have to query, is this transcribe done? Is this transcribe done? Well, I'm doing it in a step function. I'm not doing it using DynamoDB. I want to do this real-time event-driven stuff. And I have to check when the job is done instead of when the job is written to S3 or DynamoDB and it gets triggered. So DynamoDB streams is really important to trigger lambdas because it's a good way to optimize. And I say consider using DynamoDB DAX for high volume read scenarios. We're using DynamoDB Accelerator for caching of frequently accessed data. And like I said, I, I I haven't seen too many projects use it. When you decide to use it, you got to make sure you decide to pay for it. When you decide to use it, you got to decide whether this is going to cause you more heartache working across different environments. You should get a 10 to 20% speed up. And so if you have an event-driven system with a bunch of lambdas, which is what call centers look like, then you have to decide whether you want to just hit DynamoDB directly or go through DAX. And and if there's a lot of reads, you might want to consider DAX. Uh, but um, but that's your choice. Anyway, let's move on to the next video because what we're going to do is look at the access patterns and go through some of these best practices.